Hello everyone. This is my first video, so I wanna apologize for the sound or for the quality of the video. I never done it before. This is my first time, and I hope I'm doing good. Again, I want to apologize. Um, this is the presentation for the final presentation for the capstone proposal that we were working on for the class of Principle of System Administration. We're proposing a DHCP failover system. Um, my name is Juan Gil, and my teammate is Mohammad Saidur Rahman. We've been working with this for the last few weeks. We didn't have any experience. We didn't know what failover was or what a DHCP or DNS failover was. So that's how we came up with the idea. We were talking with friends from the Dominican Republic, and we came up with this idea. Um, so let's get started. Um, First of all, we have to say that the Dominican Republic, the country that where I'm from, um, in the Dominican Republic, there is no well, there is a technology infrastructure, but it's not quite as good as the one that we can find in the United States, for instance. Um, and despite the continuous efforts of the Dominican government in order to promote and facilitate the access to the internet and in order to reduce the gap, the digital gap in the faraway communities, the Dominican Republic still is facing many challenges. The Dominican Republic has a very poor electrical service, and because of this, there is a lot of problems. One of those problems is that the availability of the technological infrastructure. Um, the lack of sometimes the electricity goes off, and all the systems and all the information technology infrastructure goes down also, and all the services like DHCP service and DNS service, all those servers, they also go down, and that's a big problem within the Dominican Republic. Um, Also, in the Dominican Republic, there are free trade zones and tourist business. Those two sectors, the free trade zones and the touristic sector, they represent a big portion of the Dominican Republic's gross domestic product, the GDP. And one of those companies is Brador, which is local manufacturer of fine jewelry. They make jewels out of gold and silver, and they have a facility in a place called San Pedro de Macorís, and they have a facility over there, and they were encountering some issues with with the IT platform, and they hire some auditors to analyze their platform, and they came out with these suggestions. They said that there was a lack of DNS and DHCP failover system, and every time there was a downtime, every time the servers went down, these services like DNS, DHCP, they also went down. Um, so this is a big problem in the Dominican. This is a big problem in over there. So the purpose of this capstone proposal is to propose a failover system, DHCP failover system, that could help improve that situation within the Dominican Republic. Um, we want to identify, discuss some issues related to the DHCP service in the Dominican Republic. Not many companies implement this failover system. Um, we also want to propose a not expensive way to improve the IT platform and to improve the availability of the systems. Um, for future work, we would like to also implement the DNS failover, and we would like to do it in different platforms. Let's say we would like to do it locally and then on the cloud. If the local servers go down, then we would like to send it to the cloud, to the servers in the cloud. Let's say in the Amazon cloud, for instance. But let's try to stick to this proposal and the potential benefits of implementing the DHCP failover system would be to ensure the sustainability of a platform even when one of the components fails. In this case, one of the DHCP server fails. Also, one of the benefits or the potential benefits would be to load balancing or to balance the load between the servers. Um, and by doing that, you create a redundancy, and as a consequence of that redundancy, there is an increase in the availability time of those services like DHCP, DNS, etc. Um, why do we care? Why would we want to implement this DHCP failover system? Uh, First of all, it's all about the money. So it's all about the money. We want to make the Dominican Republic a more competitive country. And how do we do that? We have to, it's all about the money. So by implementing the DHCP failover system, this would reduce the cost of maintaining an information technology platform, and it will save time and money for the companies. It will save a lot of time, and because they they will continue providing their service without any failures in the DHCP servers. Um, let's explain a little bit what DHCP means. Well, DHCP is a client-server protocol that provides an internet protocol or IP. Um, the DHCP provides an IP to a client, to an IP address to a client, to a computer, to any kind of client. It could be a printer, it could be anything, but it provides an IP address and all the related information, configuration information, such as the subnet mask and the default gateway, or I have to say something. You can have a network, you can implement a network without a DHCP server. Let's say you make the IP address static, then you don't need a DHCP server to provide that IP address. However, with the DHCP, the entire process is managed centrally. It's automated and managed centrally. The DHCP server keeps a pool of IP address and give an address to a DHCP enabled client, which could be a PC or a printer or anything. And because the IP address are dynamic, I mean they are leased to that client rather than static. Those addresses no longer in use are automatically returned to the pool, so they can be reallocated to another client. Um, the network and the system administrator, um, they set up those DHCP servers that maintain the TCP IP configuration information, and they provide address configuration to those DHCP clients in the form of a lease. Um, so the DHCP server stores the configuration information in a database that includes a valid TCP/IP configuration for all clients on the network, a valid IP address maintained in a pool for assignment to clients, as well excluded addresses. The lease duration and the length of time for each IP address can be used before a lease renewal is required. Um, on the other hand, a DHCP-enabled client, often upon accepting a lease offer, receives a valid IP address for the subnet to which it is connecting, and it also requests DHCP options, which are additional parameters that a DHCP server is configured to assign to every client in the network. Um, However, it is suggested. I mean, some experts recommend that it is good to implement a DHCP server service. So because it this is very important. I mean, DHCP the DHCP service has many benefits, but among those benefits, this DHCP service provides a reliable IP address configuration. That means that it minimizes the configuration errors caused by setting up a static IP address, such as typographical errors or an address conflict. That's more common. An address conflict. It also reduces the network administration. You don't need a network administrator to be all the time assigning IP address, all the time assigning IP address. That costs money, and we need time is money. So since the DHCP server is responsible to allocate or to lease those IP address, so everything is centralized, and the central component is the DHCP server. Um, the efficient handling of IP address changes for clients that must be updated frequently, such as those, let's say, portable or mobile computers, um, that if they move to a different location or or another office, let's say within the facility, within the company, the forward of initial DHCP messages by using a DHCP relay agent, which eliminates the need of a DHCP server on every subnet. Um, but now, how exactly um, DHCP failover works? What that means? The first time I heard about that, I didn't have any idea of what that was supposed to mean. But it's basically two servers that operate most simple scenario, two servers that operate in a failover relationship. There is a primary server and there is a slave server or secondary server. Um, then the primary server is also called the active server, which is responsible for leasing IP address and configuration information to all the clients in the subnet, in the scope that it belongs. And the secondary server or the slave server, or the passive server, whatever, it 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 takes the responsibility of leasing IP address just in the case that the primary server becomes unavailable. Let's see this image over here. We have two DHCP servers. Um, DHCP server number one, which is the primary DHCP server. But we also have the DHCP server 2, which is the secondary DHCP server, or yeah, secondary DHCP server. But the information is replicated. The information is shared between these two servers. And let's say the primary server goes down. Let's say the electricity goes, there is a blackout in the Dominican Republic, and the electricity goes down over here. Then this server is gonna become the it's gonna take the responsibility to lease IP address. I mean, it's gonna take all the functions and responsibilities that they were supposed to be doing DHCP server one. Um, as you can see, DHCP server and the primary server and the secondary server, they share addresses, lists, reservations, policies. They have what is called a failover relationship. Um, so for this capstone proposal, we didn't specify it in the proposal itself, which is my mistake or our mistake, I would say. But I'll take it. I mean, I will do it for mm, our future proposals. Now I know I have to include a methodology section. But the way we're gonna implement this proposal is by we're gonna be using RLS. We have some limitations on resources since I wanted to create a local environment um, uh, and then a failover environment within the cloud. I mean, a second server within the cloud. Um, but we have some limitations. Well, the thing is, this capstone proposal, we will implement. We will develop it by creating within the virtual environment RLES that we've been using during the whole semester. We created, well, it says 3 Windows PCs, but we actually created 2 Windows PCs, and which are the client computers. And then we have two DHCP server, or I mean Ubuntu, two servers running Ubuntu as the operating system, and but one of the servers would be the primary DHCP server, and the second server would be the secondary DHCP server. Um, let's see how this implementation works. Let's see how this works. Let's see if this is working for real. Because at the end of the day, we have to prove that this is working. This I mean, we implement it. So here I am in my Arles platform. So as I said, I have two servers running Ubuntu. These are the two servers. I have a Piata router, and I have two clients or two PCs, which are supposed to be the clients. This is all running on the same virtualized environment. This is Arles, the one that we set up for the class. And okay, let's take a look. This is my PC. This is my client PC. Let's see. Oh, by the way, let's go. Actually, let's go to my Ubuntu server. One of them. Um, I'm gonna show you something. This is my main server, and as you can see, I just started the two client PCs, and you can see over here I run this command, the tail command, which is like a debugging command, and it shows this command shows um, this command over here, the tail -f bar log syslog Um, this is gonna check all the logs of the server of the I mean of this server, but we're looking only for the ones that are for the logs that says DHCP. We only care about these logs. So let's run this command. Right, so this is my secondary server, and this is my primary server. Um, so let's see what's happening in my one of my PCs. So config. Oh, let's see what's the IP of this machine. This one has 10.10.0.2.175. Let's see the other one. The other one says IP config. Oh, the other one has 10.0.2.174. That's the IP of this machine. But I want to do something. I want to do something. Um, CLS, CLS, and then I want to do ipconfig release. I'm just cleaning everything, and then I'm gonna do ipconfig renew. And then if we take a look at this, we can see that alright, so it took what is it? Alright, so let's see what's my new. Wait, where is it? Where is it? Yeah, let's see what's my new IP address. It's gonna be IP config. Um, so it's giving me the same address. Oh wait. So let's take a look at this. So this is our primary server. We want to stop the DHCP service from this service. So we're gonna run this command service ISC DHCP server stop. We'll see what happened. This is the log file. This is the log. This is the log file. So we'll see what happened. We'll see what happened. I'm gonna hit. So it says stop waiting. So as you can see, it says the DHCP server was killed by a term signal, and this then is gonna go to um, to the to the secondary server. It says failover. I moved from normal to communications interrupted. So let's see what happens if I start a service again. This is the main server. So over here you can see that the peer moves from communications interrupted to normal. So it means we still have IP. I mean, it's still providing IP addresses. Let's see, IP config. Oh, all right. So that's a client PC. Let me see the IP. Yeah, we have an IP address. Let me see what happens if I stop the service again. So stop. You see, we're running this command again, service DHCP server stop. So this is my log file. This is what it says, that the DHCP server process was killed. And let's see our client PC. Let's see what happens. I already stopped the DHCP server, but let's see. CLC IP config. Oh, there you go. There you go. I'm still getting an IP address. Actually, you know what? I'm gonna do IP config release again. So I'm gonna clean the IPs and then IP config renew. So I'm gonna get a new IP address. Remember that I already shut down. I mean I stopped the main server. I stopped the main server. So it's supposed we're working on the secondary one. But let's see what's happening. So there you go. There you go. I said IP config renew, and it's giving me 10.02.174. This is the IP address. Um, all right. Let me see the log. Uh, it says that at this time, this PC made a request. This PC made a request. PC1, look at this, PC1. This is the secondary server. So remember, in the first server, we stopped the server. We stop it. You see, we stop it. This is the main server. So we're going to the secondary server. The secondary server is the one which is providing IP address. As you can see, this was the one that provided this IP to this PC1, this PC1. You can see PC1. So